My name is Younghoo. I'm a principal data scientist at Sophos. I've been developing ML models for cybersecurity for about 10 years. Outside of my work, I enjoy hiking and running in the scenic landscape of Australia. Do you know what it is? It is Irish coffee. Actually, I travel all the way from Sydney to Dublin to taste it because I'm a big fan of coffee. However, if I have to choose only one between my morning coffee or my AI assistant ChatGPT, I would go with my ChatGPT because I cannot live without this powerful tool. I always use to clean up my dirty code. Also, I optimize my long SQL with these powerful tools. So these powerful LLMs play important role in our lives. So now it's time to embrace new world, multimodal AI. Let's dive into the new world. In this talk, I will cover the potential of a multimodal and how we can utilize these powerful tools for our cybersecurity problems. The first one is we can use this powerful tool to detect phishing emails, and also we can use this for website classification problem as well. The first section, I will talk about the overall multimodal AI's capabilities. Before jumping into that solution, let me talk about new threat we are facing nowadays. Generative AI can be utilized to generate these phishing campaigns. My colleague, Ben, and I demonstrate how to automate this phishing website generation using a large language model, and we use also image generation model as well as audio generation model. So we presented this one at the DevCon AI Village last year. It just took 8 minutes to create this, the new phishing campaign, and it cost about $8 last year. But now, today, we can use multimodal AI to generate this, a brand new campaign with a low cost today. Also, there are many, new phishing websites because attackers also use this powerful model to generate phishing emails. These are some of the examples. So the attackers usually target popular brands, something the Costco, PayPal, or FedEx. Let me talk about the details of these attacks. The challenges are the complex and diverse form of this cyber threat generated by Gen AI tools. However, traditional the models based on the text-based features cannot solve these problems because they usually work well for the previously known examples. So we need innovative solution to tackle these problems. LLMs are a type of artificial intelligence designed to understand and generate the human language. The main key piece is the understanding of the contextual understanding from the input. And these powerful models can capture the meaning of your input and generate relevant responses. So it can be used for many different downstream tasks. So what is the multimodal AI? It is an advanced concept. So it can process not only text, but also it can process other inputs like image or audio. So for example, OpenAI developed GPT, also Google developed Gemini, and Anthropic created Claude. This one actually supports text as well as image as input. Let me show you some of the capability of these powerful models, what we can do with these ones. The first one is for GPT. So with this input, we can ask the model to create image. So the input is the first-person view of a robot typewriting the following text, and it generated the perfect image for the text. And then the next one is a more interesting one. The robot was unhappy about the writing, and he's going to rip the paper. Can you guess what the image will be? Yeah, actually, it generated, very accurate image from your text. Let me show you another interesting example as well from Google's Gemini. So we provided the input image along with the text. The text says, is it the right order? Can you guess what the answer is? Okay, let's see. Gemini says, no, the correct order is Sun, Earth, Saturn. Now I guess you can recognize what the problem is. So the first one is actually Sun, and the second one is Saturn, and the last one is Earth. So this powerful model not understand only the text, but it can recognize all the objects in the image and provide the right answer for us. So now is the time for us to use this powerful model to apply our cybersecurity problems. The advancement of this powerful model over text-based LLMs is the understanding of the integration of multiple modality, not only from the text, but it can use the rich information from the image as well. So the main benefit is the improved accuracy for the specific task. Also, the description from this output can be used for explaining the reason behind the decision. So I will talk about how we can use this powerful model for two applications. The first one is detecting phishing emails, and the second one is a web classification problem. Okay, the first use case is phishing email detection using multimodal AI. Phishing emails often include urgent requests, something like resolving credit card payment issues, and often they include malicious URLs for credential harvesting. Attackers create the emails to resemble legitimate ones, incorporating brand images and also genuine text, but they replace the legitimate URLs with the malicious ones. So it is quite challenging to detect all these, emails using existing text-based method. The traditional machine learning method usually involves several steps: data collection, feature extraction, and then we can train the model with the extracted the features. Usually, with the text data, we use TF-IDF features. That's a token, the word token-based input. However, these models, for example, random forest or XGBoost, they rely on the frequent words in the training data. It will not detect the unseen data. Also, it cannot handle the useful the input from the image input. However, if we use multimodal AI, we can actually identify phishing attempts by analyzing, for example, our phishing emails, email headers that are useful information, and also we can ask the model to analyze the text and the image contents in the email. With specific instructions to the model, this model can actually recognize the brand identities. Also, if there's anything about the brand and that the domain name does not match with the brand, then it can actually recognize those ones as suspicious signals. So we can detect the phishing attempts with this technology without any other the external data source or minimum examples. We can detect the new threat. So we use GPT-4 as our AI model, and then we inspect the emails. So we provide a specific prompt or instruction, and ask the model to generate the report with this information. So the report will include domain inconsistency or any suspicious text or URLs or the UI. Usually when you collect the credential information, there will be the login UI. So we can detect those elements from the email. So this is one example of LLM instruction for GPT-4. So it's quite long, but basically it asks the model to analyze the image and the email headers and report these ones. The suspicious domain in the email or text, URLs, or even the image, and also it will report an overall score ranging between 0 and 1. So we can use the score as the final decision. So this is one example we detected using our prompt. So it is the phishing attack targeting Costco brand. And this one, the first one, this is actually the output from the GPT-4 and summarized what are the suspected elements. As you can see, the summary tells us there's a prompt the users to click the link, and also it identified this is about the Costco brand, and then it recognized actually the URL domain is not related with the brand. So the suspicious score was 0.8 out of the 1, so it's quite high enough to be detected as a malicious one. But when we use the additional input from the image, so this is the second summary. So as you can see, it also recognized the image. This is about the Costco, but it's not the legitimate one, and the URL does not match with one. So now we get higher the suspicious score of 0.9. So this one is a good example. So we can use, those powerful models to analyze the email headers and the text as well as the image. And similarly, we detect another one. So it's a targeting paper, and you can see that it also recognizes all the domain suspiciousness and text urgency as well as the image information. So now also you can see that the score is 0.9. Also, this is another similar example, targeting FedEx. So we did a small-scale experiment to evaluate our method works for other cases. So we trained the ML model, traditional one, random forest with XGBoost, using traditional TF-ID features, and we use GPT-4o as our AI model. So we wanted to test whether these models work for unseen data. So we did two different tests. One is a random split to see whether the models work, and another one is a brand split or the domain split. So it means it does not see any other, the same the data in the test set, which was trained on the different the domains or brand. So this table shows all the result. While random forest and the XGBoost shows high performance when we test a random split, but however, when we did the same thing with domain or random split, as you can see, the performance dropped significantly, which means these models only works very well for the similar samples. However, the next one, GPT-4o, when we use the description we previously report, so it shows that F1 score was 0.96, but when we also used the image data, the performance was improved. So in conclusion, our multimodal AI, which delivers the text as well as the image, can increase the understanding of the data, which will result in better performance. Also, as you can see, the report says everything about the decision. So you can use that information. So it increases your explainability. Okay, let me move to the second use case. So also we can use this one to classifying a website. But this time, I'm going to use another the powerful tool, which is embedding models. So we can generate the text description from the website. So website has the image as well as the HTML content. So we can generate something similar, the text description. But also, what we can do is from the text description, for training a machine learning model, we need to numerical representation of the text. So we can use another model. So the surge of non-safe work contents on the internet poses a significant challenge for web classification or filtering. However, the existing text-based one does not handle all those, different contents. Also, they usually limited understanding of the visual information. So our solution is to employ large language-based embeddings to find a similar website. This slide explains the embedding models and their roles in the semantic similarity search. So this diagram shows the input is the object, which means that words or sentences can be the input to the model, and that the embedding model will convert the text data into the numerical representation. So for something like these numbers will be the output. But this number allows us to measure the similarity between different sentences. So the second diagram shows a space of sentences in 2D dimension. So where the similar sentence will be located close. For example, the little boy is running is close to the little boy is walking. So this way, actually, we can find the similar website. So the embedding models are quite essential in ML classification task. For instance, our problem, so the word gambling or casino will be closed, located in the close. So we can use those information. In a traditional approach, the steps involve data collection, extracting HTML contents from the URLs, and the tokenizing features. So at this time, also we use token-based TF-ID features to train the traditional models. Also, we used to use OCR to extract the text from the image, but this one is only limited to the textual information. It will not recognize previous, like the Earth or Sun. However, if we use the multimodal AI, we can actually create detailed description about everything within the text HTML data as well as the image. So we use GPT-4o to generate those descriptions. We ask the model to look into the screenshot of the website. So if there's anything important object, it will describe. And also, it will find all the information from the HTML data as well. So for example, it's quite important, like usually the gambling website, there's like poker chips or roulette table in the website. Those are quite the useful information for us. So, and also when we get the text description, the next step is we need to convert this text into the numerical representation. So for us to train another model. So this model, actually we can use another embedding model to do that. So our final workflow involves these kinds of steps. So we first generate text description using GPT-4o. So we use the HTML data as well as the image screenshot. And then we use another second model, which is the OpenAI's embedding model. The input is the description, but it will generate numerical vectors. And then we can train the model random forest or XGBoost. So, okay, this is the one example. Can you guess the category of this website? It looks like a sports one. But if we look at carefully, it's not the one that actually it is sports betting gambling website. So when we used only the token-based feature from the raw HTML, actually the model recognized this one as sports. But when we use the multimodal AI to describe all the details about the image as well as text, it was recognized as the gambling correctly. And then you can see that all the details from the model. The first one is about the HTML data, and the second one is from the screenshot of the image. And this is another example. So, but it's a slightly different problem. So this is a non-English website. I cannot actually understand the text, but actually the powerful GPT-4 actually translated this one, image as well as the text into English. So now I can read what are the text, and actually recognize the website as a gambling one. That was the correct answer. And this is another totally different problem. So can you see anything in the useful information from the text? No, actually you can get everything from the image itself. So now this is the power. Actually the model can recognize, oh, these are the weapon. So it recognizes this website as the weapon. That's the correct answer. And this is another one. Actually, you can hardly get the information from the text, but the image itself tells everything. So yeah, the model was recognized this one as the weapon, not the sports. So also we did a small-scale experiment to test the effectiveness of this one. So we used the random forest and XGBoost model with the traditional TF-ID features. Also, we used the embedding features from the embedding models. And then we measured the precision record and the user F1 score. And the best performance we got from the embedding models when we used the image as well as the text input. So this table summarized our test result. As you can see that when we use the embedding from the HTML and the image, we got the best performance for the different models. This experiment result demonstrates that the embedding from combined text and the image produce best performance. And yeah. So in conclusion, our study highlights the impact of a multimodal AI against the evolving threat. By leveraging multiple modality from the text image, actually we achieved a significant performance improvement over text-based method, which is setting a stage its wide usage in cybersecurity. As I mentioned earlier, I would choose AI assistant over my morning coffee. Actually, it was not a bad decision, as I can get my coffee using multimodal AI. Actually, it has some limitations. I cannot smell the aroma yet, but I guess next year I will have perfect coffee using OpenAI, ChatGPT, or something else. Thank you, everyone.